Uh, Good afternoon, my YouTube viewers. It is Crystal here, and I wanted to make another video for you on hypothesis testing. And basically, the last video I made, we did a z-test with 2 samples and 1 towel. And in this video that I'm going to make for you, we're going to do a z-test with 2 samples and 2 towels. The difference between a 2-tailed sample and a 1-tailed sample is on a 2-tail sample, it checks both tails of the distribution, whereas on a 1-tailed sample, it only tests 1 tail of a distribution. So the first thing that we're going to do is we're going to get our data. And so what we're going to do is we're going to use a rand between 75 and 125. So that's going to give us an integers between 75 and 125, and it's going to be 100 elements in this array. And then sample 2, it's going to be the same, rand between 75 and 125. Because what we're doing is we're checking the IQs of people. So I don't have any data of IQs of people, so I just had to make it up. So I'm just saying, well, most people are going to fall between 75 and 125, but you know, some people will be lower and some people will be higher, but we'll just keep it between 75 and 125. After we've got our sample data, then what we want to do is we want to set our significance level. So you can set the significance level up to whatever you want. You can set it's usually 0.05, which is 5%, but it can be 0.1 or 0.5. It can be whatever you want. At the moment, we have a significance level of 0.1, and the p-value is less than 0.1. So it's giving us a false null hypothesis, which means that we cannot accept the null hypothesis. And because the means of sample 1 and sample 2 are not the same. And so what would happen, it would mean that you would accept the alternate hypothesis. So the null hypothesis are the means of the 2 samples are the same, and the alternate hypothesis are the means of the 2 samples are not the same. So we just say here, come over here to the alternate hypothesis. Okay, so whenever I did all this typing, what has happened has caused the random numbers to change. And when the random numbers changed, it went from a false to a true. But what we could do, so now we've got a mean of 97.89 and a mean of 101.49, but we can change it and then see what happens. And so when you change it to 0.05, that's 5%, then what it's going to be easier for the means for the null hypothesis to be accepted, because it has to be above that level before it can be accepted. But if you want it to be more difficult for the null hypothesis to be accepted, then you make it 0.5, and we've got a false, because that's making it more difficult for the null hypothesis to be accepted. So then it will have to take the alternate hypothesis. But we'll just make it 0.1. Okay, so because it can be anything you want it to be, and we're just trying it out. So the mean in sample 1 is we're going to use the average formula in Excel from A3 to A102. And the mean in sample 2, we're going to use the average formula from B3 to B102. Now we're going to check our standard deviation. So the STDEV.S, which means we're checking the standard deviation of the sample from A3 to A102, and then for the standard deviation for the second sample is STDEV.S, B3 to B102, and then the .S is letting you know that it's checking the sample. And then because it can be a .P, which means it's checking the population, and S, which means it's checking the sample. So ideally, the sample is going to be less than the population. So variance 1, we're checking the sample, so equals var S dot S, A3 to 102. And then variance level 2 is equals var S, B3 to B102. Then we say sample size 1, we're using the count. Count is A3 to A102, and then sample size 2 is count, B3 to B102. Now we check our test statistic, and this is the formula that we're going to use for the test statistic equals E4 minus G4. So we're going to subtract the means from each other, and it's going to be over the square root of the variance, that's E6 over E7. So the variance over the count for sample number 1, and then sample number 2, it's going to be the variance over the count. And that's going to give you a test statistic of 1.2. And then we check our p-value. And the difference between the p-value that we're using in this example is the same as the p-value in the previous example with the 1-tail, except for now you're going to multiply it by 2. So you're going to use the same formula, the same Excel formula, norm.s.dis, and then it's going to be E9, which is your test statistic, and false, which means it's your probability. And you're going to multiply that by 2. So that's the difference between a 1-tailed and a 2-tailed. The 1-tailed is checking only 1 tail, and then the 2-tailed is it's checking both tails. So since you multiply it by 2, that means your p-value is going to be larger in the 2-tailed p-value than it is the 1-tailed p-value. So now we're going to check for the null hypothesis. The null hypothesis is E10 is greater than E2. So if E10 is greater than E2, then that means you're going to accept the null hypothesis. If it's less than E2, that means you're going to reject the null hypothesis and accept the alternate hypothesis. So let's see, we've got a p-value of 0.47. So let's try it here, 0.5. So again, we've got still a very high p-value, and so it's real iffy because we've got a mean of 101.12 and a mean of 102.19. So that means that there's one number difference between mean 1 and mean 2. We can say 0.6, see what happens. Again, you got a really good p-value. You've got 1-digit difference between the two p-values, so 0.7. So we've got a false here. So that means the p-value is less than the alpha or the significance level, which means that you cannot accept the null hypothesis, and you have to go with the alternate hypothesis. But 0.7 is quite high. Try it at 0.5. Again, that's true. And again, you've got a very high p-value of 100.76 sample 1 mean, 100.45 sample 2 mean. And so that's telling you that the means are very similar. Change it to 0.1. Again, you've got very, very high means. Mean 1 is 100.14, mean 2 is 101.3, so it's not too bad. So what we could do is if we wanted to change change the samples, like make one sample different than another, then that would give you more information. So we'll say between 60 and 140. So we're going to actually change the two samples. We're going to change the numbers of the two samples and see what happens. So here we've changed the numbers of the two samples, but the means are still the same. The means are still the same even though we've changed the numbers of the two samples. So let's go ahead and change it. Let's make it like 80 to 140 and see what happens. So here you've got a mean, in sample 1 you've got a mean of 102.49, sample 2 you've got a mean of 111.74, and you have a very low p-value because the means are significantly different. So we can change it to 0.05, and it's still false even when you change it to 0.05. So that was a good example to show you what it's like when you have means that are obviously different and how the hypothesis test works out. So that was a good idea to do that. So I've covered everything that I want to cover in this video. I talked about random integers using the rand between. I talked about alpha using the significance level. Talked about the mean, the standard deviation, the variance, the sample size. Talked about the test statistic. Talked about the p-value and the null hypothesis. So we've talked about everything that we can talk about in this video, so I'm going to go ahead and close it. So if you like my video, please like and subscribe. Thank you so much for watching my video. I look forward to making another video for you, and we will talk about some more statistical subjects in Excel.